Hey, welcome to Maker Faire. Good, it's not still morning anymore, is it? Good afternoon, and thank you for taking some time out of your busy lunch schedule. You could be eating food, but instead you're here checking out me, Brian Jepson, Don Coleman, and who couldn't be here physically, but in spirit, Tom Igoe. We're the Three Stooges, the three authors of a book called Beginning NFC, which is all about sensing the presence of tiny little things with your phone, and I don't mean your kids. So, Don.
All right, so we wrote a book for O'Reilly, and we've recently shipped it off to our editors, so hopefully the electronic version will be out soon, and then the print version after that. I don't have exact dates.
Because the editors won't find any trouble with it.
So we're going to just kind of give you a brief overview of some of the stuff that's in the book, and hopefully have some demos from there that'll work too. We use NFC in a bunch of different places, but first of all, a little bit about NFC.
Did we say what it stands for? Let's say it again.
Near field communication. And
so, really close.
Near field communication is kind of like RFID or radio frequency ID, but instead of having things far away, we're talking about this far or this far. A lot of times you're going to have tags that are like this. They have a little tiny chip and then an antenna. And so this tag is passive, and it's powered by power from my phone, power from an NFC shield, something like that. And so with the tags, we can read data from the tags, and we can write data to the tags.
There's basically a spiral antenna that energizes, and this also has a little spiral antenna here, and it gets energized, and current flows through it, and it replies with a radio signal.
And so tags come in all shapes and sizes. There's some bigger ones like this, some small Samsung ones. There's some guys doing a Kickstarter. They actually have a ring with an NFC tag embedded into it. They sent me one of them, which is kind of cool. The thing to remember about NFC tags is they hold a very small amount of data. A lot of the tags we use will hold 1K. Some of them will hold like 39 bytes. So very, very small amounts of data.
But even when we have a 1K tag, it's 1 kilobyte of memory, we only really have about 768 bytes that we can use. But then there's also the limit of our own intelligence and how good the libraries are that we are able to write, or how lazy we are sometimes as programmers, and we might not want to cross a boundary of memory in the RFID chip, the NFC chip, so we try to keep our messages short.
Right.
At least speaking for myself, because I'm a very lazy programmer.
So one of the things we did when we started working on this book is there was libraries to do really low-level NFC, to write bytes onto tags and to get bytes off. But to make things so that I could write a tag with my phone and read it with the Arduino, that was a little bit tougher. There's something called NDEF for NFC Data Exchange Format. And basically that's a way that you can write data onto any tag and read data off of any tag and have interchange between different devices. So one of the things we did is we wrote a couple different libraries. We wrote one for PhoneGap to do NDEF, and we wrote another one for Arduino, and then another one using Node.js so you can use it with a BeagleBone or a Raspberry Pi.
And effectively with these little messages, an NFC sticker, you can write a message to this with your phone or with an Arduino, put the sticker up on a wall, and it's basically a little piece of graffiti that somebody else can come by and read with their phone. It's really pretty cool.
So one of the things we did is, since it's really fun to use phones to do this, there's a lot of Android devices and more coming out every day that allow you to read and write tags. We wanted to write libraries to do that. The only problem is you had to write a lot of Java code, you had to learn a lot about Android to be able to do that. There's also BlackBerry phones and Windows phones that had NFC tags on them, and we wanted just an easy way to be able to read and write that. So one of the things we did is we wrote a library for PhoneGap. And what PhoneGap is a project or a library.
By we, he means he.
Group effort that allows you to write applications using HTML and JavaScript. And so the great thing about that is it's a lot easier to write JavaScript. We tried to distill the library and make it fairly easy to do. So with, 20 or 30 lines of code, you can be reading and writing tags. And if you're interested in that, I'm actually going to be talking more about PhoneGap later today, just how PhoneGap works. But for now, all you need to know is that it's called PhoneGap NFC, and there's a library you can read and write tags. We have a demo of that that kind of works in with one of our other demos here. And to set the stage for that is we have these tags here, which we're going to say there's kind of like a hotel room.
Let's tell the folks who that little robot is on your
Okay,
screen.
this is the PhoneGap build bot. So he's just for the PhoneGap project. If you want to learn more about PhoneGap and how to use that, it's phonegap.com.
And 3:30 today, you're going to be here talking about PhoneGap on this stage.
Yeah. So one of the things with PhoneGap is we have some sample applications, and one of those sample applications will allow you to read. Hopefully this is actually going to work here. So if we have this here, we can put a tag behind it, and it will read and print out the data that's on the tag. So there's just kind of a diagnostics app that's sample that comes with PhoneGap. So it's kind of neat if you actually get that PhoneGap app, you can go and you can read a bunch of tags around.
And it'll actually do that without you even writing a line of code, right? Because that's the sample app?
Yeah, if you install the sample app. So the other thing we do with this is we wrote an app, and this rig over here is going to simulate a hotel door lock. We'll get to that in a minute. But one of the things we need for that is we need to be able to write the data to a key so that as I check into the hotel, it's going to store some data on an NFC tag, and we'll use that to open this lock.
And you probably can't use this to hack your hotel, but we're not saying that you can't.
This is a proof of concept. So if we have my name here and I'm going to check into room 3327, and we hold a tag here and it says that I've been checked in.
So that's the front desk.
And now we'll change this and we'll write Brian a different tag.
Thank you.
And put him in room 55. And we'll write another tag for Brian. And we could actually go back and look and read these tags.
I think it read it as
there we go,
right
Brian in room 55.
Thank you.
And then Don in room 3327. So these tags we'll use for our next demo.
Why do you get the top floor?
What's that?
Why do you get the top floor? I'm down on floor 5.
Preferred status. So when we get to the Arduino, there's basically two main shields that can be used. Today we're using the Adafruit shield, which if you're not familiar with shields, it's a piece of hardware that plugs into the Arduino, and there's basically an NFC reader, and there's a chip, which is the same chip which is in this Android phone here, in that shield. There's a second NFC shield that Steed Studio makes. It uses the same chip in there. There's a little bit different drivers. Our library will support either of those. Brian, you want to talk a little bit about the kind of setup that we have here to make this work?
So this is diagram of an Arduino Uno, and did we do this diagram in Fritzing?
Yes, Tom made this in
Fritzing.org, which is a great way to diagram and even do your own circuit boards. And so what we've got here is some indicator LEDs that we can use, and they can be turned on and off by a pin. We've also got, that's a MOSFET there.
Yep.
And what we're doing is we're using the transistor to turn a solenoid on and off that'll knock the door off its hinges. Open the door. So what's not shown here is the NFC shield that plops right on top of the Arduino. And some of the pins on the NFC shield are wired directly to Arduino pins, which means we can't use those pins for the rest of our project, but that's okay because, hey, the rest of our project is actually the NFC shield. So here we're watching the debugging output from the Arduino sketch, because you probably won't.
Hopefully we can see it'll print a little diagnostics information as things go. So one of the reasons we have to use a transistor here is because the solenoid in this lock draws too much power, so we can't drive that directly from the Arduino. We have to use a little bit higher current for that.
Because it probably it may even kick some current back after it stops, and we don't want to find out.
So basically we have some code that I uploaded to here, and what this code does is it looks for a tag to come in, and then it looks for a specific type of tag, as well as having information like about the my name and stuff on here, there's a tag, and we made a MIME type called text hotel key. So that way if we try to read some other tag, it just ignores it. It only looks for tags that it knows about, and then it looks for the room number, and if it's the right room number, it checks the check-in and the checkout date. So if all works here, now that went really quick, I'm gonna do that again.
Yeah.
So if we look here, it says my name, my room, and the check-in, check-out. And so if you watch the lock solenoid, it goes in, and the green LED comes on when a good tag works there. Now, if we take Brian's tag, and we put it here, it says it can't unlock the room, and it also has a red, the red LED goes. It's a little tough to see in this bright light.
I suppose that's what I get for trying to break into Don's room.
Now, I made another tag that was, it had check-in and check-out dates from last month. So even though this is the right room, it says, hey, thanks for checking with us. You've already checked out, so it won't open it. And even more so if we try to read a tag here that doesn't have key information.
It doesn't like it at all.
It doesn't work. Okay, forget that part of the demo. Anyway, so the cool thing about this is it was pretty simple to write. If we switch over to the sketch, I think it's a couple hundred lines of code, if that. All this code is available with the book, and there's going to be a GitHub repository that comes with it. And basically we go and we set, there's a little bit of setup that says, hey, get the shield working, set some pins for stuff, and then we have a loop where we basically say, listen for a tag, and we say if there's a tag present here, well, man, if I could scroll here, we can get the NDEF message off the tag, we can get stuff out of the message, and it's fairly straightforward to make that work.
And all of his code is really easy to find because on GitHub, he's just Don, D-O-N, and he's taking offers. Bidding starts at $5,000 for that name.
And then so here's a picture of the same setup built a little bit different. So we cover phone app with phones, we cover Arduino, and then we also, we're not going to demo it today, but we also show how to use with the Raspberry Pi or the BeagleBone Black. You can get a USB reader that plugs in, and you can do a lot of this same stuff. We use a library called libNFC and libFreeFair, and then we have some Node.js code that runs on top of that, so you can write JavaScript to run on your BeagleBone to make the same stuff work. We like JavaScript because it's really easy and really accessible for anyone to get to.
It's officially fall. So I think we'll have time for some Q&A, but I know there's probably one question that at least one of you has. What I'm showing here are mostly NFC tags, but there's one thing that's a little weird. The one in the corner there, and that's a Bluetooth low energy tag. How many of you are wondering whether Bluetooth low energy is going to render NFC obsolete? I mean, it's okay. All right, so there's at least 3 people who are as geeky as I am. That's great, or as we are. So, the answer is probably not, because what is this thing here? This is first of all, you notice it's thicker than the other tags because it has a battery in it. So to the extent that it's anything like RFID or NFC, it's more like an easy pass reader because it's active. It's waiting to be talked to. So I guess we can switch to the app here. And what you'll see is that it's really for different types of uses. So I can say, where's my sticker? And, oh, cool, my sticker's been found. And although it looks like a radar, it really can't tell where it is. It can tell about how far away it is. But this thing's consuming power. These things don't consume power. This thing, I really can't write a message to it. I mean, in theory, I could if I designed it that way. But if you look, it's very hard to see, but that says 72 degrees Fahrenheit. That's because this has a temperature sensor on it. So it's almost like another little computer. And I can page it, and it'll beep and glow. So it's very different. It requires power. It requires, you have to change batteries. it's something that's just as fun. Bluetooth Low Energy is just as fun as NFC, but it really is for different situations. I don't think you'd make a hotel room key with this. Otherwise, you'd have guests coming down all the time saying, the battery in my key is dead. And there's no point in doing that.
So you may have seen there's been some articles out recently like, hey, Apple's not doing NFC, is Bluetooth going to kill NFC? And I think those are kind of a little bit sensational and trying to grab headlines. They're really two different things. One of the nice things about NFC is as a user of NFC, you get to control it. NFC only works when I'm putting my phone near the tag or my tag near the device, where Bluetooth is more of a broadcast. So people are kind of lumping them together where they're two totally separate technologies. They can exist together and they can do different things. Sometimes you can have some overlap, but in general, there's it's not necessarily a direct competition there.
One big difference is that if I stick this on you and you don't know it's there, I can pretty much know when you're nearby. If I stick this on you and you don't know that it's there, I have to get really close to you to find out if you're there, and by that time, I already know you're there.
So, thank you guys for listening. We'll take some questions if you guys have questions about NFC and other stuff, and we'll do our best to answer them.
How does this relate to things like the classic key card, security key cards that you're using when you wave in front of the detector?
Sure. So the question is how does this relate to the classic key cards that you wave in front of the detector? The answer is yes, it is the same thing. Those are a technology called RFID, and those RFID operates in a bunch of different frequencies. NFC is backwards compatible with a certain type of RFID, so they're very closely related, and in a lot of scenarios, they're essentially equivalent. So they're definitely, and kind of a related question is there are older RFID tags that are very, very, very insecure and can be easily manipulated, cloned, spoofed, so hacked.
A lot of times with the RFID, you're just reading an ID hard-coded on the tag, whereas with NFC, we can actually write data and read data from the tag too. You can do that with RFID, but not as many people do it. You got a question there?
Is there a library covering MyFair? So MyFair is a certain type of card. There's MyFair Classic, MyFair Ultralight, and actually the answer is that the libraries that are MyFair oriented, actually.
Yeah, the PhoneGap library covers MyFair Classic and Type 1 through 4 tags. The Adafruit library, or for the Arduino library, reads and writes MyFair Classic and will read Type 2 tags right now. And the Node.js library is only MyFair Classic right now.
And there's a little bit of an issue there because the MyFair Classic, which is at the moment, if you find an NFC tag in the wild, especially one that you can read and write to yourself, not some hotel key, most of them, for some reason, are MyFair Classic, which is fine, it works great, but the only problem is it's not one of the NFC standards. So when Google came out with the Nexus 4, it won't read or write the MyFair Classics. It'll read or write the MyFair Ultralights. But so what we need really is for on the Android side and on the Arduino side for the libraries, and actually Don, you're kind of working on that, to converge on the standardized tags. Otherwise, we're going to stay in the situation we're in where there's some tags out there that can't be written to. From different devices that should support it. So I think we have 5 more minutes. So probably.
Did you have a question right there? No. Go ahead.
Two questions. First is, can you explain what the difference is between RFID and NFC? How they relate?
So the question is how NFC and RFID are related. I touched on this a little bit earlier, but RFID came first. Worked on a bunch of different frequencies like 125 kilohertz. But then eventually, when NFC came out, they came up with a standard that included NDEF, I believe, at 13.56 megahertz that stayed backwards compatible with a certain set of RFID. So you can think of NFC as an evolution over RFID. So
yeah, it's a subset of RFID, and the big thing is NFC is only going to work very close, whereas RFID, you can be scanning things like where you guys are out there. I could have a reader that would be scanning for RFID. NFC is really close range.
And before we take your second question, let's give the person up front a shot. just in case we run out of time. Sure, is there any way to secure it or prevent someone from copying your card? The best thing is that the newer tags, especially the ones that are part of the NFC form specification, to a limited extent, with the exception that we really don't know what the long-ranging impact of the NSA's manipulation of security standards might have on this, are about as secure as anything else that we trust as being secure.
But
which is to say, we don't really know.
yeah.
Did you want to do his part 2 question? And
Sure.
that'd be our last one.
Part 2 was, can I take like a key fob off this
So the question is, it's very related to your question. Can I take a key fob from the office, replicate it, and then use the copy of it? And I think the answer is maybe.
Yeah, it depends. At least in my office, they use it's a different frequency, so my phone won't read it. I think you can read it if you use the Adafruit reader in RFID mode. I do know that on the MBTA in Boston has RFID cards. I talked to someone that said he's cloned that and put the ID on his Android phone. So maybe you can do it. Those are cool projects to look into, but I haven't personally got that to work.
So I think that 2 minutes. We've got 2 minutes. So why don't we do one more question? Hey, maybe we're out of questions. So, okay.
You compared NFC to Bluetooth, and from a cost standpoint, the NFC is way cheaper.
Yes.
Right?
Yeah. The question is Bluetooth versus NFC cost difference. Even though the Bluetooth low energy tags are cheap, Stick and Find was something I got on Kickstarter, and I don't know, it was probably 10 or 15 bucks a tag, and then you get the battery cost. Whereas if you have these manufactured or you buy them on AliExpress or eBay, 80 cents, 90 cents each?
Yeah, I mean,
less.
if you're buying thousands, I think you can get them down to 30 cents. If you're buying one, it's like $2.50. So somewhere between there, you can get them really cheap. What's that? Stickers are about the same price. Actually, I think some of the MyFair Classic, some really small tags, you can probably even get them down to 20 cents maybe if you buy enough. So.
Okay, we got time for one more. Sure, that's a good question. The question is about security, how you block stuff. Many of you know that all the newer passports have RFID, or I don't know if that's NFC, in them. You can buy a metal mesh container, a solid metal container that will prevent them from being read, even if somebody brushes up against you. So.
Well, there's some encryptions with the different types of tags when it gets into like a MyFair Classic and stuff like that. MyFair Classic had its encryption broken a while ago, that's why people don't use it. MyFair Ultralight has a newer encryption, and that's mostly to write and then write protect them, to prevent them from being modified. As far as to prevent them from being read, that's very tough to do.
Right.
So if you want to keep your content secret, you need to encrypt it before you write protect, and then have your reader know how to decrypt it.
But that won't prevent it from still reading your ID.
Right, you could read it, you could clone it potentially. It
So
depends.
if they read your ID at point A and read your ID at point B, they know you're probably the same person.
So.
Okay, well that's, okay. Well, the conductive filament inside the tags you're asking about? The tags, could you use conductive filament? You might have to weave it. I mean, you really ultimately, if you want to keep somebody from reading it, you need a Faraday cage. So it would have to satisfy that. So.
Cool.
Okay.
Thank you.
Yeah, and we'll stand around here. Thanks very much.